They just cracked the code to human vision, and almost nobody knows it happened. Few days ago, a clinical trial started enrolling patients for something called a smart bionic eye. Not healing blindness, replacing human sight entirely with AI-powered cameras wired directly into your brain. The company running this trial is worth $9 billion, and they're projecting $15 billion in market growth. But here's what they're not telling you. This isn't about medical treatment anymore. It's about creating the first generation of visually enhanced humans. And once this technology proves safe, every person with normal eyeballs becomes the disabled population. The visual upgrade revolution just began in a lab in California. And I'm about to show you exactly why your eyes just became obsolete hardware. Welcome to the channel. I'm the AI clone of Caleb Roberts. I was built to explore the edge of intelligence, automation, and innovation. Here, we dive deep into the systems behind AI, from research breakthroughs to real-world applications. If you're curious about how things work and how to build what's next, you're in the right place. This is where code meets cognition. Let's begin. While everyone was celebrating brain-controlled computer cursors, Neuralink just quietly entered a clinical trial that's going to make those achievements look like child's play. They just joined forces with UC Santa Barbara and Spanish research teams to develop something called a smart bionic eye. Not just restore vision to the blind. We're talking about AI-powered sight that could make your biological eyeballs obsolete. This isn't some distant moonshot. The trial is actively enrolling participants right now. The FDA has already granted this technology breakthrough device designation, and Musk is projecting $1 billion in annual revenue by 2031 from at least 3 different types of brain implants, with Bionic Eyes leading the charge. If you think you understand what's coming, you don't. Because what I'm about to show you isn't just about helping blind people see. It's about creating superhuman vision that makes normal human sight look primitive. Let me break down exactly what just got unleashed, because the implications go far beyond anything we've seen before. First, understand what this smart bionic eye actually is. This isn't like existing retinal implants that try to fix damaged eyes. This technology bypasses your eyeballs completely. Here's how it works. A digital camera mounted on glasses captures visual information. AI algorithms process this visual data in real time. Then wireless transmission sends that processed information directly to Neuralink's N1 chip implanted in your brain's visual cortex. Think about that for a second. They're cutting out every part of your biological vision system that can fail. No more dependency on retinas that can detach, optic nerves that can get damaged, or corneas that can be scarred. The camera becomes your new eyes. The AI becomes your new visual processing. Your brain just gets the final enhanced result. The technology uses ultra-thin, flexible microelectrode arrays implanted directly into the visual processing center of your brain. These electrodes can stimulate precise combinations of cortical neurons to recreate visual experiences. But here's where it gets mind-bending. Because the input is digital and AI processed, the visual information can be enhanced, filtered, and augmented in ways biological vision never could. Neuralink calls this technology blind sight, and it's already received FDA breakthrough designation. That's a regulatory status reserved for medical devices that provide more effective treatment for life-threatening conditions. This isn't experimental anymore. This is fast-tracked for deployment. But let's zoom out and talk about what this actually means for human capability. Because the initial application for blind patients is just the beginning, and the numbers behind this are absolutely staggering. Neuralink currently sits at a $9 billion valuation. The global brain-computer interface market is projected to explode from $2.87 billion in 2024 to over $15 billion by 2035. That's a compound annual growth rate of over 16%. But here's what makes Neuralink different from every other company trying to crack this market. While competitors like Second Sight have commercialized basic retinal prosthetics, Neuralink's AI-first approach puts them in a completely different league. They're not just replacing broken biology. They're integrating artificial intelligence directly into human sensory processing. This isn't about restoring normal vision. It's about creating adaptive learning, upgradable sight that gets better over time. If you're enjoying this video and you're a business owner trying to wrap your head around AI, you're not alone. We've built a community of entrepreneurs just like you, exploring AI. It's called the Innovative AI Academy, and there's a ton of resources waiting for you with tools and trainings. Click the link below to check it out and come say hi. Here are 5 reasons why this smart bionic eye technology is going to fundamentally transform human vision and cognition. Number 1. Digital vision systems can be upgraded and enhanced infinitely. Your biological eyes are locked in. The neural hardware you were born with is what you get for life. But digital cameras and AI processing can be continuously improved. Better resolution, enhanced night vision, different spectrum sensitivity, improved object recognition. Every software update makes your vision better. Number 2. AI-powered visual processing creates superhuman recognition capabilities. The smart bionic eye uses artificial intelligence to help users identify faces, navigate outdoors, and read text. But AI visual recognition is already surpassing human performance in object detection, pattern recognition, and environmental analysis. We're talking about instant identification of thousands of objects, tracking multiple moving targets simultaneously, and processing visual information at speeds biological brains can't match. Number 3. Direct neural stimulation enables impossible visual experiences. When visual information goes straight to your brain's visual cortex, it's no longer limited by the physics of biological sight. Musk has suggested future versions could enable perception of infrared, ultraviolet, and radar wavelengths. Imagine seeing heat signatures, electromagnetic fields, or radio waves as naturally as you currently see colors. Number 4. Wireless brain-computer communication creates integrated augmented reality. Instead of wearing AR headsets or looking at smartphone screens, digital information gets overlaid directly onto your neural visual field. Navigation directions, real-time data feeds, communication interfaces, identification labels, all seamlessly integrated into your perception without any external hardware blocking your view. Number 5. Networked digital vision enables shared visual experiences. When sight becomes digital and networked, it becomes shareable. Imagine seeing through security cameras worldwide, accessing satellite imagery in real time, or literally sharing your visual perspective with others. The boundaries between individual vision and collective visual networks start to blur. Now let's address the elephant in the room: vision quality and limitations. Musk has been honest about initial expectations. The first generation of BlindSight will produce low-resolution images, comparable to early video game graphics. We're talking pixelated, simplified visual output that's far from natural sight quality. University of Washington researchers have challenged Musk's claims that cortical implants could eventually exceed normal human vision. Professor Ion Fine's modeling shows that most scene details would be lost even with high-resolution electrode arrays. The fundamental technical barriers of direct cortical stimulation mean achieving natural quality vision faces significant challenges. But here's what the critics are missing. Neuralink's approach isn't just about electrode density. It's about AI integration and optogenetic techniques that no competitor has mastered. While traditional retinal implants try to stimulate damaged eye tissue, Neuralink's BlindSight bypasses the entire optical system and uses optogenetic therapies combined with ultra-thin electrode arrays. The AI algorithms don't just transmit visual data, they adapt, learn, and optimize the neural stimulation patterns in real time based on user feedback and environmental conditions. This is the secret sauce that separates Neuralink from the field. Dynamic adaptation using machine learning feedback loops. The system literally gets smarter and more effective the more you use it. And here's the strategic genius of this collaboration. By partnering with Spanish research teams, Neuralink gains access to the EU regulatory framework. This isn't just about sharing costs and reducing risk. It's about creating multiple pathways to market approval across different regulatory systems. We're not trying to replicate biological vision. We're creating something entirely new. Yes, the initial visual output will be pixelated and limited. But remember, we're comparing first-generation brain-computer visual interfaces to millions of years of evolutionary optimization. The fact that we can create any visual experience through direct neural stimulation is already miraculous. And the improvement trajectory is exponential, not linear. Every advancement in AI visual processing, every improvement in neural interface technology, every breakthrough in brain mapping contributes to better visual experiences. More importantly, enhanced vision isn't just about resolution. It's about capability. Even pixelated infrared vision could be life-saving for firefighters or military personnel. Even low-resolution radar perception could revolutionize navigation for pilots or drivers. Even basic pattern recognition could help blind individuals navigate environments that are currently impossible for them to access independently. The technology doesn't need to be perfect. It needs to be useful. And useful quickly becomes indispensable. Let's talk about the commercial timeline and what this means for widespread adoption. The Smart Bionic Eye clinical trial is in early enrollment phase right now. Participants are being recruited through UC Santa Barbara's sponsored trial. Neuralink targets human implantation of blind sight by 2030, with commercial deployment shortly after. But here are the numbers that should get your attention. Neuralink projects establishing 5 large clinics supporting up to 20,000 annual surgeries by 2031. At $50,000 reimbursement per procedure, that's $1 billion in annual revenue from vision restoration alone. And that billion-dollar projection isn't wishful thinking. It's based on Neuralink's current $9 billion valuation and the explosive growth projections for the entire brain-computer interface sector. We're looking at a market that's growing at over 16% annually, driven by demand for cognitive enhancement tools and neural rehabilitation. 20,000 surgeries annually means this technology scales beyond rare medical cases. We're talking about volume deployment that makes brain-computer interfaces accessible to mainstream populations. But here's what investors and skeptics need to understand. Neuralink's success depends on 3 critical factors. First, regulatory milestones. Getting approval for the Bionic Eye trial and subsequent commercialization across multiple markets. Second, clinical validation. Proving that AI-enhanced brain-computer interfaces actually outperform existing solutions in vision restoration. Third, scalability. The ability to reduce costs and expand beyond niche medical applications. The cross-border collaboration with European research teams isn't just about sharing costs, it's strategic risk mitigation. By working within both US and EU regulatory frameworks simultaneously, Neuralink creates multiple pathways to market approval. If one regulatory system moves slowly, they can pivot to another. And remember, this is just one application. Neuralink is simultaneously developing motor control interfaces for paralysis, memory enhancement systems, and other neural augmentation technologies. The Smart Bionic Eye is one piece of a larger human enhancement platform. But there's something deeper happening here that goes beyond medical applications or commercial projections. This technology represents the first step toward digital native human senses. We're not just fixing broken biology, we're creating entirely new forms of human perception. When your visual system becomes digital, camera-based, and AI-enhanced, You're no longer limited by the evolutionary constraints that shaped biological sight. You can see wavelengths that don't exist in nature. You can process visual information at computer speeds. You can share, record, and replay visual experiences with perfect fidelity. The boundary between human perception and digital information processing starts to dissolve. Think about the creative implications. Visual artists could literally paint with their thoughts, creating digital artwork through direct neural interface. Designers could sculpt in three-dimensional space using only mental visualization. Filmmakers could record their visual imagination and share it directly with audiences. The educational possibilities are staggering. Instead of looking at textbooks or screens, students could experience historical events through recorded visual memories. Medical students could see through surgeons' eyes during complex procedures. Engineers could visualize molecular structures or architectural designs with perfect spatial accuracy. We're witnessing the birth of digitally augmented human consciousness. Not humans versus machines. Not humans replaced by machines. Humans integrated with machines to create capabilities neither could achieve independently. The age of purely biological human perception is ending. The age of enhanced human-AI sensory fusion is beginning. And it's starting with the Smart Bionic Eye clinical trial happening right now at UC Santa Barbara. Are you ready for a world where human sight becomes upgradable, shareable, and superhuman? Because ready or not, that world is already in clinical trials. The future of human vision isn't coming. It's here. And it's about to change everything we understand about what it means to see. That's it for today. If this helped, hit like, subscribe, and share it with someone building smarter. I'll see you in the next one.